This is Algebra 1, Term 6, Lesson 3, Measures of Center and Spread. We'll begin in Desmos' classroom, and then we'll do a fun activity, How High Can You Fly? And then we'll finish up with this GeoGebra task. So let's get started in Desmos. This is the Desmos classroom activity. There are 18 screens, so it will take some time to do these calculations and to analyze the data. So on this first screen, they will be calculating measures of center using the Desmos Graphing Calculator. This Graphing Calculator button is used on nearly every screen. So the ones on the top are blue. If you have colorblind students, be sure to let them know the blue is on the top and the red is on the bottom. And so I'll go ahead and do the blue with you so you can see how this will be typed in. Click on the calculator button and then type in a list. I'm going to choose a B for blue, equals, and then open with square brackets, and then type the numbers into this list. You will notice that there's 15 elements in the list, so that's a way of kids checking, and you may tell them that, like maybe put it up on the screen. The blue one has 15 points, so be sure you have 15 points. And then they'll come down here to the bottom, and they will find the mean. So you'll type the word mean, and then you'll put the name of the list. And remember, I chose B, but they could choose a different name for their list. They could capitalize their letter. Whatever they choose, though, they have to type in the parentheses. And then we'll do median. So we'll go to the next row, MEDIAN, and we'll type B. So that's how that works. So just have them type that in. They'll repeat the process for red. Now, I would not delete anything. Tell them just to add another row to do red. And the reason I say that is because you'll notice that this button is kind of colored blue now. That's because Desmos, in the goodness of their heart, has now made the calculator that's in the Desmos activity save. In other words, when students go to screen 2, in the past, they would lose all their calculator data and they would have to redo it. But now they've retained that. So now I'm going to click next, and you'll see I'll go to the next screen. See how the calculator button doesn't look highlighted anymore, but look at this one. See how it's highlighted? When I click on this, that data that I put in there is still there. So that's super valuable. That way, if a kid's getting a different answer and they can, notice, oh, wait a minute, you didn't get the same mean I got. What did I do? And they could go back and check their data, maybe make an adjustment if they've made an error. Anyway, once they've done that, they're going to answer this question. Why do you think these are called measures of center, the median and the mean? All right, they're going to do this again for range. This time they're looking for the minimum and the maximum, and they will subtract the minimum and the maximum to get the range for each set. So they shouldn't really have to use a calculator to do that, but if they need it, it's there. The next screen, they're going to do the IQR. Now, they're going to need the blue set again. So let me show you something else. They don't have to retype all that. The kids, some will do it, but they don't have to. So what they'll do is they'll come over here to screen 1, and they will highlight this list, all of it. Make sure they got it all. Do Control-C, and that copies that list. Go over to screen number 3, open the calculator, and paste. Control-V will paste that list. So there it is. All they had to do was copy and paste. So they did not have to retype all that. Remember, the stats, STATS, is the 5-number summary, and then they'll put the name of the list in the parentheses, and it gives them the 5-number summary. Now, if you'll click on it, it will remove the keyboard so that they can see all of that, and then they can just type it into this box. Now, IQR is not something it displays. It expects you to do that. So the distance between the 2 and the 6, which is Q1 and Q3, that would be a 4 in this case, is the IQR for that data set. And so you would just type a 4 into this box. They will repeat the process for red. Again, I would encourage them, do not delete anything. Go ahead and leave it in there. That way, if you have to come back and change something, or if you've made a mistake, it'll be there for you. When they get to the next screen, they will create 2 dot plots that are symmetric, they do need to be different. So see if you can encourage them to make them look different, but make them both symmetric. So different shapes maybe, but both symmetric. They are going to calculate their data again like they did last time. The mean, the median, the range, and the IQR. Now the mean, they just type mean and median, and the IQR, they will subtract Q3 minus Q1. If they'll do the 5-number summary, it has all three, the median and the IQR, and then they can subtract their min and their max to get their range. Now this next set of data is symmetric. So before they change anything, they need to answer this question 1. How are the mean and the median related when the data is symmetric? Again, we are repeating a problem we did over and over in the last lesson, and we'll do again in the next few lessons. So this is going to be one of the main ideas they need to take away from their statistics lessons. Once they've answered question 1, they're ready to do this middle piece here. Drag the green point to the left. They can go all the way to the left, or they could stop short of that. Somewhere in here is fine. And once they do that, they're going to answer this question. How are the mean and median related when the data is skewed right? On this one, they're going to modify one data set. So here we have the mean and the median for the blue are both 4, but the mean and the median for the red are not both 4. So they want all the means and medians to be 4 here. So we're going to adjust the red dots, which is the ones on the bottom for the students that are colorblind. Be sure you tell them. So just change these and make the median a 4. You might also talk about, is there more than one way to do it? Now here's the thing, if you want to do it another way, you have to remember how it was, and that's something that's kind of a challenge. So if you'll click on this edit list, there is a reset button, and it will set that slide back to its original state so that they can see what it was when they started and maybe try again and see if they can come up with a different arrangement. On this one, they're going to describe how 2 sets of data that have the same number of elements can have the same median and the same mean, but still have a different shape or spread. So talk about that. This may be a good time to pull in graphs of different students and talk about, you've got something that looks really different from this other student. Can you talk to me about what's different and why is the median still the same and the mean is still the same, but y'all have different shaped graphs? All right, on this one, we're going to move just 1 point. So we're going to take something from 3 and we're going to move it out towards the edge of the graph. I'm not using the term outlier at all here, but we are going to be introduced to the term outlier in this lesson, and then we're going to define it very specifically in the next. Students probably already are familiar with that term, as I've said before. The next question is, how did moving that point from 3 to the edge affect the shape, the center, and the spread? So the shape would be skewed left, skewed right, and symmetric. Measures of center, that's your median and your mean, how were those affected? And spread, that would be your IQR and your range, how were those affected? All right, modify both data sets this time. Make them different. Make the mean for B, which is the ones on the top, 6, and make the means for A also 6. But let's see if we can make them look completely different. And then here, this is an unrelated question, but it's similar, but it's not about that particular data set. They're going to select 2 statements that are true. This has to do with the center and the spread for each set of data. And now we're going to look at some actual numbers in the real world. These are salaries of people that work at an American company in thousands of dollars. What did these reveal? So they're going to do their 5-number summary. They will use their graphing calculator and do that. They will do the range, the IQR, and the mean, and then they will give their opinion. What is your opinion of these salaries based on this data? The next screen, they're calculating standard deviation, and yeah, it's something nobody really wants to do, but unfortunately this was in my standard, so I had to do it, and this is kind of the only thing I did. I did like one example of it, and then we used the calculator from thereafter. So we will do that in this class as well, but this does show the process that's used to calculate standard deviation, and all they have to do is arrange these steps in order, and we're calculating standard deviation for a 4-number set of data, 3, 4, 6, 7. It's pretty easy to put in order just by reading this, and they will check their list. It will tell them when it's correct. All right, now we have salaries that were from that previous screen in that table, and I have created a list. You might notice these are square brackets. I've showed you that earlier. This is the name of the list. It tells you how many numbers are in the list. They're going to calculate standard deviation. So this is the first time they've done it. They will type STDEV, open parentheses, and put the name of the list. So this one is a capital A, so it does have to be capitalized, and then it will give you that standard deviation. You may want to pause here and talk about what this means. What does 43 represent? It actually represents $43,613. That's a lot of money. So that is the average, I guess. It's kind of like how far the average person's salary in this company is away from the mean. And that's huge. That's a huge standard deviation for salaries. When they get to screen number 15, they're going to go ahead and make some predictions. If you took the person who made the $185,000 a year out of this company, if they left and that salary was deleted from the list, what would happen to the median? Now, it's very important that you're pausing your kids as they go through here so that they can really talk and think about this, because some of this stuff is revealed later. So let them think about what might happen if that person leaves. Look at the other salaries. What will happen to the mean? What will happen to the IQR? How about the standard deviation? Will that change, and why? All right, now they're going to actually remove it. Now my suggestion here is when they do these calculations, so they're going to type mean parentheses A, I would go ahead and type all of this in first and then remove the number from the list. Now it's actually here on the right, so be careful. If they accidentally delete their list by clicking this X, remember they can reset and it'll put it back. So tell them not to freak out if they accidentally do that. It's bound to happen. I've done it myself. You can also undo. So I think if you delete this, you can undo it. Let's see if that works. Yeah, if you undo, it'll come right back. So no big deal. Don't freak out. They're going to go ahead and do all the calculations, and then I would remove that number, and then I would do the calculations again. And watch the change. See what's happening. And you can even undo removing the number to go back and then maybe remove it again if you need to just kind of toggle back and forth. What's happening to the mean, to the median, to the standard deviation? What's going on? All right, and then it gets even more fun. We're really going to show by actually playing this P. Now notice this is a box plot. It's really tiny. There's the box. The box represents the IQR, interquartile range. You've got your maximum, you got your minimum, you got your Q1, your Q3. Okay, you can't hardly see the median in there, but it's in there. All right, let's go ahead and click play and then look at what's happening. You may notice the values, they all change. Even the median is changing, but not much. The median barely changes. The mean is going crazy. The standard deviation is really changing. So the question at the top of the screen is which statistics are changing and which are staying the same. On the next screen, we talk about there are some statistics that are resistant to outliers. So we talked about outliers being far away. They're way outside the norm. We should know that this 185,000 is definitely an outlier because it's so far from the other salaries in this company. When we removed that, some of the statistics really changed and some did not. The ones that really change, we say, are sensitive to the outliers, but the ones that did not change much or didn't change at all, we say are resistant to outliers. And so here I'm asking two questions. Which measure of center is resistant to outliers? Is it the mean or is it the median? And then finally, which measure of spread is resistant? That means it's not going to change much if you take out that big salary. Which measure of spread is more resistant to outliers? Is it the standard deviation or the IQR? And that sums up our Desmos activity. So our next activity is how high can you fly? Now this activity I've done actually in a different place in my class. I used to do it when I gathered two variable stats and then we compared our arm span, I think, and height and something like that. But this is actually good for single variable stats. So I thought, I think I'll put it here. What they do is I give them these little removable stickers. You've probably seen them. They have them at the dollar store, the little packets with the little dots, the colored dots, and they write their initials on their dots, and then they go out into the hall, and I had a little spot on my wall where they could jump up, and then they'll create a list and a box plot in Desmos for all the heights of all the stickers in their class. If you would like to, you can lump your data, because I did have one class that was small. I only had like 14 kids in one of my classes, and then I had one class with 25 kids, which is a pretty good number. So it just made for better data when I clumped them together. I used a Google form to help them gather their data and then sent them a copy of the data. You may also choose to input the data yourself and then just send the link out to the Desmos calculator with a list in there. So that's up to you. I like to give them opportunities to actually create their own lists because that is a skill they will need. Then they will calculate their mean, their 5-number summary, and the standard deviation for the data. They will describe the distribution of the data. That means is it skewed left, skewed right, or symmetric? And do any points appear to be outliers? In other words, is one data point significantly far from the others? They won't be counted wrong if they're not at this point because we have not defined how to calculate or to determine that. The calculator does have the ability to remove outliers or keep them in, so they may know it that way, and that's great. Anything they can figure out on their own, I'm all for it, but we're not really getting into that in this lesson. Let me show you an example of the stickers on the wall. I have a cute little picture of that. Okay, so here you see a little spot outside my classroom that was perfect for this. It was a little, I don't know, it's like a divider between me and the neighbor teacher, and then I put a little tape measure here so you can see it, and maybe I did centimeters, I don't really remember, but the kids would put their initials on these and get up here and post them. Now some of them were, this tape measure went all the way down. I actually tore it off later because it got I don't know, it was just kind of flailing in the wind, so I took it down. But I'll leave that there all semester so they can remember this activity. And you can see there's quite a bit of data in the set. I don't know, I don't think I actually combined the data though. I think they actually just used their own, but I left everybody's up there so they could see it. It's kind of fun. It's kind of noisy. I had to warn my neighbor teacher, okay, y'all aren't taking a test today, right? Because I'm having them jump up and down in the hall, and I don't want them disrupting you. And but it was fun. It's a great brain break, so I would do it in the middle of class if I were you. But that's what it looks like. Now, if you want to really turn this into like an all-day affair, you could have them create like posters with their data and their distributions. You could even have the classes each do a poster, maybe put them side by side and compare. So you could have some fun with that. I just intended to do a quick activity here, but you could turn it into more than that if you'd like to, or if you have time. So our last task is to visit GeoGebra, and we're going to use a box plot to get an intuitive understanding of how outliers work. So let's go to GeoGebra. Now in here you'll notice the median is given. You'll also notice it says LQ, that stands for Q1, and UQ, that stands for Q3. LQ means lower quartile, UQ means upper quartile, and in America at least we use Q1 and Q3 for that. So the question is, I want to be able to create outliers. Now, they're not going to necessarily know how to do that, but if you try to push a point over these boundary lines initially, it's not going to work. And so to create outliers, they're first going to have to cluster these numbers way closer together. So talk about the spread of the data is really pretty broad for a test. These are test scores, I believe. Points on us. The line represents scores of 50 students on an exam. So we got students scoring in the 20s. Well, that's pitiful. Let's see if we can help those poor children and get these scores a little higher. So let's get all the scores more clustered together. And as you'll notice, these fences are moving in. These are like your boundary lines for your outliers. You don't have to tell them that initially. I would let them play a while and see if they can figure out what's going on. But if they'll get these all clustered in close, then when they grab a point, they'll be able to go outside the boundary line, outside the fence, and see how they turn red. So they need to create an outlier on one side for one of their data sets and on the other for the other data sets. And you can see how the graph above is being affected and how the median is changing as well. All right, once they've done that, they're going to come over here and paste a picture of their graph, and then they will describe what they did to create that outlier. So that would include getting those points in a little closer together, because initially they're so spread out that you can't really make an outlier. You can't get out far away enough to make the outlier. So they had to do that, and then they could create the outlier. So again, they're building intuition for what outliers are and how they work. You may have noticed that on the screen itself, it has the formula down here for the outlier. Like you take your lower quartile and you subtract 1.5 times their IQR. We're going to use this formula in the next lesson, but you'll notice I'm not even talking about it. If they notice it, great. If they figure it out, great. I'm okay with that, but I don't really care if they know the formula as much as what's, it has to be pretty far away. In other words, you can't just push a point to the edge of the graph and call it an outlier. All right, they're going to do the same thing again. This time, let's skew the data left by creating an outlier, one outlier on the left. Same process. Insert a screenshot. Describe what you did to create that outlier on the left. And it's not just picking up a point and moving it left. You had to kind of get your points clustered together. Now, here's a fun one. We're going to create a symmetric distribution, but we want the median score to be 80. So if you'll look at your plot, it does have the median score, and that's pretty bad. This is only a 58. So they're going to have to really do a little bit of work to get these scores up. So let's take our lower scores and move them way up. We want symmetric data, so we don't want any outliers here. It says you can have outliers with symmetric data, but it does say here do not have outliers. So they want to have no outliers, median score 80. And then they're going to screenshot their graph and number line, and then I want them to compare their graph to other students. So the ones in their team, maybe outside their team. You could even potentially go in, have kids put some of their graphs on their slides, and you could put some up and go, look at this one. Does anyone have one like this? And, you could go look at their slides. So as the kids put their stuff on their slides, I often pull kids' slides up for the class, and we talk about it and compare the different graphs. So they should be able to come up with different graphs that have the median score of 80. And this concludes our lesson, Measures of Center and Spread. We have one more lesson before our first Term 6 test. Y'all have a great day.